The atmosphere is the thin gaseous veil around the Earth. It consists of gases, suspended particles, and liquid or solid water. The atmosphere is held down by the gravitational pull of the Earth. Its density decreases rapidly with altitude. The lowest 60 miles of the atmosphere contain 99.9999% of all gases. The atmosphere is subdivided into the homosphere and the heterosphere. The homosphere refers to the inner atmosphere. It reaches from the surface to approximately 50 miles altitude. It is the sphere where the gases are evenly blended. Even though the concentration of gas molecules decreases drastically with height, the percentage of permanent gases, such as nitrogen, oxygen, and so on, remains constant within the homosphere. The heterosphere refers to the outer atmosphere. It reaches from 50 miles upward. Layers of gases in the heterosphere are sorted by gravity. Lighter gases, such as hydrogen and helium, become increasingly dominant with increasing altitude. The homosphere is composed of permanent and variable gases. Permanent gases occur in a constant proportion throughout the homosphere. The main permanent gases are nitrogen, oxygen, argon, and other noble gases. Variable gases are those gases which vary in concentration with time and space. The main variable gases are water vapor, carbon dioxide, and ozone. The thermal layers of the atmosphere. The vertical profile of the atmosphere is characterized by sections where temperatures decrease with altitude and other sections where temperatures increase with altitude. We find the troposphere, the stratosphere, the mesosphere, and the thermosphere. The troposphere is the lowest layer of the atmosphere. The word stems from tropos, Greek, which means turn, and refers to atmospheric overturning. It is heated from the Earth's surface. Temperatures in the troposphere generally decrease with height by an average lapse rate of 6.5 degrees Celsius per kilometer, or 3.5 degrees Fahrenheit per 1,000 feet. This is the normal lapse rate. The troposphere stretches from the surface to 10 miles above the tropics and 5 miles over the poles. It contains more than 80% of the mass of the atmosphere. It is the layer where virtually all weather processes take place. The top of the troposphere is called tropopause. The stratosphere is the atmospheric layer which is located on top of the troposphere. The word stems from stratus, Latin, which means layer, and points towards the lack of vertical motion or overturning in this part of the atmosphere. It stretches from the tropopause up to 30 miles above ground level. It is an area of little weather, even though some exchanges of gases occur between troposphere and stratosphere. The top of the stratosphere is called stratopause. Temperatures in the stratosphere increase with altitude. Average temperatures at the tropopause are approximately -74 degrees Fahrenheit. Average temperatures at the stratopause are approximately 28 degrees Fahrenheit. The increase of temperatures with altitude is called temperature inversion. The inversion in the stratosphere is caused by the absorption of ultraviolet radiation by ozone and oxygen. The mesosphere stretches from 30 to 50 miles altitude. Temperatures decrease with altitude as no increased absorption of radiation occurs. The top of the mesosphere is called mesopause. The thermosphere stretches from 50 miles altitude upward. Temperatures increase with altitude and approach almost 3000 degrees Fahrenheit due to the absorption of cosmic radiation. However, the heat content of the atmosphere is very low due to the low density of gases. Atmospheric functions. The ionosphere. The ionosphere stretches from 30 miles upward. It contains large numbers of ions, which are electrically charged particles. The ions are formed through the absorption of cosmic rays such as gamma rays, X-rays, and some UV rays. The interactions between the ionosphere and particles emitted from the sun cause the aurora borealis, which are the northern lights, and the aurora australis, which are southern lights. The ionosphere is subdivided into the D, E, and F layers with increasing altitude. The transmission of radio waves relies on the reflection at the ionosphere. The D and E layers diminish with reduced solar radiation, allowing the F layer to reflect radio waves to further distances during the night. The ozonosphere is part of the stratosphere, which is characterized by high concentrations of ozone. Ozone absorbs ultraviolet radiation and converts it to heat energy. The absorption of ultraviolet radiation in the ozonosphere is vital for life on Earth, because ultraviolet radiation is highly energetic and would prevent any biological life if it was permitted to reach the Earth's surface unfiltered. Ozone is formed by the absorption of ultraviolet radiation by oxygen. One oxygen molecule absorbs very short-wave ultraviolet radiation and forms two unstable oxygen atoms. The unstable oxygen atom combines with an oxygen molecule to form ozone. Ozone is sustained by reactions that involve the absorption of ultraviolet radiation. One ozone molecule absorbs ultraviolet radiation and is broken up into an oxygen molecule and an oxygen atom. The unstable oxygen atom combines again with an oxygen molecule to form ozone. Human activities have interfered with the stratospheric chemical processes, mainly by releasing chlorofluorocarbons, CFCs, into the atmosphere. The result is a partial depletion of the ozone layer. Here is how it works. CFCs release chlorine into the ozonosphere. Chlorine reacts with ozone to form chlorine monoxide and oxygen. Chlorine monoxide reacts with a single oxygen atom to form chlorine and oxygen. The chlorine atom remains unaffected through chemical reactions and can destroy many thousands of ozone molecules.